All right, guys, this is the first two lectures for week 5. So we're to the point right now where we're starting to put together kind of our the data collection aspect of our proposal. And so I'm going to do a presentation first that talks about quantitative research, and then I'll do another one that talks more about analyzing qualitative research. So there's going to be a lot of stuff in this, guys, that you won't necessarily need for this paper, but I'm going to go through it anyway. And it is what it is. We'll figure it out and get through it. So first thing you need to understand is that with qualitative data, there can be bias that can happen, particularly when you do survey. You can have response bias when there's a significant kind of a systematic difference between people who respond and don't respond, meaning that you're getting a group of people. So for instance, let's say you were trying to survey everybody about an election, and you had a larger response of, say, Republicans or Democrats than you did the other one. That would be an example. You could have a sampling bias where you don't have where it doesn't reflect how your population is, and then you can have you can just flat out not have the right measurement, meaning you're not measuring what you're trying to measure. So if you're concerned about having a bias or not having a sample large enough with your survey, then you have to keep going through processes in order to make that sample pan out. You can notify people prior to giving them the survey, follow-up reminders. You can provide giveaways or things like that to help people respond more. There's a bunch of ways you can go about getting more people to respond. So as you get your data, the first thing you want to do is you want to make sure that it's that there's no abnormalities. So we're just making sure we can read the data, that it's legible, that it's all complete, it's consistent, and that it's accurate. Okay, meaning you didn't get people answering it twice, things like that. And so then you have to start to kind of figure out how you're going to code the data. And this is just giving you kind of an overview of just ways that you can create questions. So one is for closed-ended questions, where you give people kind of a list of possible responses. So male, female, or like a Likert scale type of responses. And so there's several ways that you can measure things, or scales or measurements. You can use nominal scales, which, they have no order. You're simply asking like what position you play in baseball. You can have ordinal scales, which are ranking, which is it kind of has no meaning to it. So for instance, first place, second place. You can have interval scales where you have kind of a continuous measurement. So something similar to like a Likert scale, like a level of dissatisfaction 1, very satisfied 7. We've all taken those. And you can have just a continuous variable where you just ask simply like a fan's age. So when we start looking at statistics, and that's one thing you're going to have to decide, those of you that are doing quantitative data, is what I need to do to get the answer based on what my data is. So you can use descriptive statistics, which you will use for sure. This just kind of gives you a summary of your data. These are things like central tendency, variability, relative position. We'll go through these individual relationship. These are all descriptive statistics. So we've all seen these. Central tendency are things like mean, median, mode. And, if you have your data in an Excel sheet, you can get Excel to do it for you, or you could use a program like SPSS. And these just kind of give you just generic information about your about your data. You can do variability, which tells you how much your scores are spread around the mean or another measure. So you look at range, standard deviation, variance. These are all measures that tell you how far something is from the mean. One that's most commonly used is standard deviation. You can get relative position. So this is it's going to indicate where a score is located in relation to the rest of the distribution. So you're probably used to seeing this in like percentile ranks, like if you've taken like a standardized test. You can also see it like in standard scores. So you can get like a z-test score, a t-test score, which is basically letting you know how far away you are from the mean. And then you can measure things by relationship, which they can tell you to what degree two variables are related to each other. So a correlation coefficient gives you a range from -1 to +1. If it's close to 0, it means there's really no relationship. If it's stronger toward -1 or +1, it tells you basically that there's a strong positive relationship or there's a strong negative, meaning that the two variables are either going in the same direction or they're going in opposite directions. And so then you can do inferral statistics, which is basically where you're analyzing the information from samples and you're trying to draw this out to a larger population. And so this is where you get more into, I guess, higher level statistics. You start taking tests that give you statistical significance, this is when it really comes down to it, guys, this is everything. So basically significant means that it's true or not true to chance. So in most statistical tests, 0.05 is what's considered statistically significant. And so what that helps you do is it helps you decide to either accept or reject the null hypothesis. Okay, and we test the null because it's easier to disprove the null than prove the alternative. And that's something some of you guys are going to have to add to that, because if you're planning on doing quantitative research, you have to have both hypotheses in there. And so I'll talk about that more when I show you an example for what I'm looking at as far as the research design. So when you basically have statistical decisions, there's 4 possible choices. You can get that the null hypothesis is true, which means there's no difference. And the researcher concludes that it's true. You can have that it's correct, the null hypothesis is actually false. Okay, then you can have errors. Your type 1 error is the null hypothesis is actually true, and your type 2 error is the null hypothesis is actually false, and the researcher concludes that it's true. So this doesn't happen a ton of times, and this is not that important to you. It's a little higher level because you guys actually aren't going to run any of the stats, but it's just something that you need to understand. And so the power of statistics lies in basically the probability that you reject the null hypothesis when in fact it's false. And in other words, you make the correct decision. That's what we're looking for. So basically every goal is to basically detect the difference when it truly exists. We're trying to basically find what we predict. This is not so much important to you guys, but it's talking more about directional hypothesis, which at this point you guys don't need to know as much. And just understand that what we want to happen is if we say we'll just go. I'll show you this when I pull up the example paper. It's going to make more sense what this is talking about. And then once you make once you get your stats, then you have to get an effect size. And what that means is it's measuring how much the effect is, the magnitude of it. Okay, and so just because a test is significantly significant, so it's 0.05, doesn't mean that it's meaningful. And so this tells you whether that is actually meaningful. And probably the most common one used is Cohen's D, and I'll show you kind of what that looks like in an example. So when you're trying to decide what test to use, you kind of ask kind of a couple questions. What's the purpose of your research question? How many dependent variables versus dependent variables? Do you have covariates? And then what is the goal for your analysis? And so I'll post some either videos or articles about how to pick the correct test. And look, like I've told you the whole time in this class, you just want to try to make the best decision you can, and I'll help you iron the thing out. So, you might want to know what the degree of a relationship is. You could know, is there a difference between two groups? You could try to do stats and make a prediction of membership in a group. Or you could look at something that studies the underlying structure that can kind of explain why a set of variables are what they are. And so ultimately we're trying to draw some conclusions where, we're able to summarize and explain our results. And we're wanting to be able to compare our results with results from the literature that we review. And then we want to be able to talk about the implications of our study, basically, also, in theory and in practice. And we want to be able to have a discussion where we provide people with, based on our research, with suggestions for future research. So, like I said, guys, I will post some videos about helping you pick statistical tests if that's in what you're going to do. But for right now, I just want to kind of give you an overview of it.